And in case you need a little video introduction to the experiment part that I'm asking you to do, you're going to go ahead and click on Run Experiment here. I would like you to choose a solid. Go ahead and pick our unknown metal. You pick a mass, you pick a temperature. Don't show the specific heat. Over here in liquids, we're going to, next. In liquids, choose water. You pick a mass. We're going to go ahead and pick a temperature. Let us pick 20. You can show the specific heat for the water. And we're going to start. You definitely want to make sure that you're recording initial masses and temperatures of both of these guys. Initial masses and temperatures of the metal, initial masses and temperatures of the water. The final temperature is going to be the final temperature of both the water and the metal. That's super important to think about. So this change in temperature is going to be the final temperature for the water and the final temperature for the metal. Because the metal was giving heat away until it matched, got to equilibrium with the water's temperature. So super important thing, this is the final temperature of the water and the metal. So when you go back to your the lab handout, you want to do Q equals mc delta T for your metal, mass, specific heat you don't know, temperature change. Mine went from 140 down to 21.47. Right now I have two unknowns for my solid, so I can't really solve for anything yet. I don't know the C and I don't know Q yet. But if I go over to water, I do know the specific heat of water. And so I can use my mass of water, my change in temperature of the water went from 20 to 21.47 Celsius. So I have a delta T, and I do have a specific heat for water. So I can calculate the Q of the water, how much heat did the water gain? And that's going to be equal to the heat lost by the solid. So then you can use, let's see if I can get this to write on the screen. So you can do Q equals mc delta T for the metal, Q equals mc delta T for the water. Do the water first. Solve for Q. Let's say it's like 50. Take that Q, the energy that was gained by the water, and you're going to set it equal to the Q of the metal. So the metal lost the 50 that the water gained. The metal lost the 50 that the water gained. So then you can plug in your mass. Still don't know C. You can calculate delta T, what's that temperature change, and then solve this for specific heat. Once you have that, compare it to the table that's in the Google Doc, and voila, you have identified the metal.